All right, we're going to go through a few concepts. Again, I label these as quizzes, but really they're knowledge checks. Pause the video, decide what you think the answer to be, and then watch the solution. All right, so fly spatters itself on the windshield, which has greater magnitude. This is asking about the forces on the car versus the fly. The correct answer here is the magnitudes of the forces are the same. Now, of course, the results of what the fly looks like after this, they run into each other, is very different than what the windshield looks like. But what happens to the fly's acceleration depends upon the net force the fly experiences and the fly's mass. Similarly, the acceleration that the windshield experiences depends upon the net force on the windshield and the mass of the windshield. But just as a reminder, when we talk about Newton's third law, where we're saying that every action has an equal and opposite reaction, we can write out a statement describing the fly pushes on the windshield. The fly in this case is the object. The windshield is the acting agent. Newton's third law tells us that these two objects are involved in the reaction. In the reaction, the windshield becomes the object. Oh, I guess I got those backwards. If we're saying the fly pushes on the windshield would be the object, the fly would be the acting agent. But in either case, it's the same two objects that must be applying the force on each other. And so, however hard the fly pushes on the windshield is how hard the windshield pushes on the fly. The difference in the results is coming into play in terms of the other forces acting on the fly, and then that really tiny small mass of the fly gives that fly a very large acceleration, which in turn the physical construct of the fly is not strong enough to withstand it running into the windshield. The acceleration of the windshield also depends upon the net force, but the net force on the windshield specifically. The windshield is connected to the frame of the car, so it has a strong force holding it onto the car or truck, whatever it is we're driving in, car. The net force on the windshield, this large force of the frame holding onto the windshield versus this little force the fly applies, divided by the mass of the windshield, which is very large in comparison to the fly. And so there's no noticeable difference in acceleration of the windshield once the fly hits. Of course, there's a smear on the windshield, but that's a different story. So Newton's third law, same two objects, always involved in the action-reaction. Let's look at one other question for this quiz. Pause the video, answer. All right, ground, we have this baseball. We totally know the baseball has a force of gravity acting on it. We have a normal force acting on it. We need to pick the correct statement. So gravitational force is not independent of the mass. We calculate that knowing the mass. the Earth exerts a much greater gravitational force than the ball exerts on the Earth. That cannot be true, because Newton's third law is telling us that if we're talking about the ball versus the Earth, we would say the action was either the Earth acting on the ball gravitationally or the ball acting on the Earth gravitationally. So those forces need to be equal and opposite. That's what Newton's third law is telling us. So option C, the gravitational force on the ball due to the Earth is exactly the same as the gravitational force on the Earth due to the ball. C, totally. Now, E is a very common answer, but it is not correct. It is not correct because the normal force is caused by the floor. Not the Earth as a whole, just the floor. The floor pushes up on the ball. Gravitational force is a gravitational attraction of the ball towards the Earth as a whole, not just the floor. So Newton's third law always, has to have the same type of force, and it always needs to involve the same two objects. Okay. Now, it is totally true that the normal force equals mg in this case, but that's because the net force on the ball is 0, because there's no acceleration. This is true because of Newton's second law. The motion of the ball, whether or not it has an acceleration, is directly related to the net force on it, but just on the ball itself. Newton's third law is talking about how any two objects interact. I'll have a couple more videos involving concepts. I'm just breaking it into smaller videos. So test your understanding on those as well.